Section 5.1 is estimating with finite sums. So we're going to be looking at finding distance traveled when velocity varies. So we all know that if velocity is constant and time, so if we're going 60 miles per hour at a constant rate for 3 hours, we know that all we have to do is multiply 60 times 3, distance equals rate times time, to get the accumulated distance. But what happens when velocity varies? So a particle starts at x equals 0 and moves along the x-axis with a velocity of t squared for time t. We want to know where is the particle at t equals 3. So if it's a constant rate, we would have no problem. Multiply rate times time to get distance. But as that rate changes with a function like t squared, our computation will change. So we're going to graph v and partition the time interval into sub-intervals of length delta t. If you use delta t equals 1/4, so we're splitting up, let me put the graph up, we're splitting up 0 to 3 into 12 pieces. So each change of t is 1/4 of a unit. The area of each rectangle, now granted these aren't rectangles, but we can draw rectangles here. We can draw them in a variety of ways. I can draw them across the middle. We'll talk about that in a minute. The area of each rectangle approximates the distance traveled over the subinterval. Adding all of the areas gives an approximation to the total area, or the total distance traveled from 0 to 3. So let's take a look at how we're going to do this. So our subinterval is broken into 1/4. That is our delta t. And it's the length of the base of each triangle. The top of each triangle comes from our function, which is the midpoint. They're using a midpoint squared. So let's go back to our picture. So they're going to use the midpoint of each rectangle. Since they are forced, the midpoint will be 1/8, 1/4, 3/8. You get the picture? So using the midpoint of each interval, they're going to form a rectangle. So the midpoint is 1/8. The height at that point is the function value. And the area is the height times the base. Our base width is 1/4. Our height varies as our function varies. And by adding all of these up, calculating the area of each little interval, we get all of these equations and we get this value, which is approximately 8.98. So left rectangular means we're going to use the left side of each rectangle. You can see that they've done a smaller thing here. This is still y equals x squared. Instead of delta x being 1/4, they've split this into 6 pieces. So each piece, or our delta t, is 1/2. On this graph, we've used the left side of each interval. On this side, so that's my LRAM, this side uses the midpoint, looking at the midpoint of each interval. And this one uses the right. So I'm going to let you pause this video and go back to your work that you've done on this before and see if we can come up with some answers. Okay, so I'm going to show you the work in class, but let's see if you got the answers correct. This one I got 55/8, or approximately 6.875. This one was 143/16, or approximately 8.9375. And this one was 91/8, or approximately 11.375. So see if you can get those values, or if you got those values. If you didn't, try one more time, or we will go over it in class. So I'm not going to show you all the work for that. I want you to go through and do a refresher. I want to see the work on your notes when you come to class. The last thing is using the program that we entered. So we are going to estimate the area under the graph of x squared sine x. So we're going to apply the RAM program, which is the one that we talked about. A is going to be the left side. It's capital A in your program. So when the A prompt comes up, you're going to enter 0. B is 3. So in other words, we're going from A to B. N is the number of subintervals. In this case, we are going to use 1,000. Now, this is nothing, we would never do that by hand. And we're going to use the left endpoint approximation. So when it asks you for percent, you're going to put in 0. With this particular program, the left endpoint of your interval is 0. The midpoint would be 50%. The right side would be 100%. Okay, so you have 2 tasks to do. One is on the previous screen to show all of your work for left, midpoint, and right. You're going to do that manually without your calculator, hopefully getting the solutions I've provided. And then using that RAM program, see if you can come up with an approximate area of 5.77476 using these entry values when the program prompts you. Now it's going to take a while. It has to go through 1,000 sums, and it's going to scroll through that. So you might need to just let it run and then come back and look at it. It'll take maybe, I don't know, a minute or so to run through the entire program. All right, so that's your task for the next class, and that's it for 5.1.